Just very quickly to start Newton's second law of motion. Newton's second law of motion is describing a situation in which we have an object and the net force acting on the object is not equal to 0 newtons anymore, as it was in the case in Newton's first law of motion. So it's the kind of an opposite situation to Newton's first law of motion. We have an object that is not in equilibrium. Net force on the object is not equal to 0 newtons anymore. And to use Newton's first law of motion terminology, if I have an object in such a situation when the net force is not equal to 0 newtons, if the object was at rest, now it is not going to be at rest anymore. It is going to start to move. An object that were moving at constant velocity at the same speed in a straight line, as soon as net force is not equal to 0 newtons, those objects will move at constant velocity, and their velocity will start changing. And both of those ideas could be put together by saying that an object acted upon by non-zero net force will accelerate. So we're talking about acceleration. Newton's second law of motion is about acceleration. And it doesn't stop just by saying, Newton didn't stop by saying that non-zero net force produces an acceleration. He went on and he actually defined how big the acceleration will be depending on the magnitude of the net force. To make the long story short, the equation describing the Newton's second law of motion is telling us that the acceleration is proportional to the force, and it is inversely proportional to the mass of the object. So the more massive the object is, the smaller the acceleration. The less massive the object is, the larger will be the acceleration when acted upon by non-zero net force.